Hello guys, I am a student of DAIICT and currently we are working on a project in discrete mathematics that is inspired by our respected professors Professor Manish Kumar Gupta, Professor Manoj Rao and Professor Prosenjit Kundu. This is our team and there are 6 members in our team. I am Dishant Patel and my student ID is 202201260. As you know, if you have watched the previous videos, then you have idea that we are working on the algorithms behind Google Map, how Google Maps uh, use Dijkstra and A-star algorithm to navigate us and find the most cost efficient way, and it helps us a lot. Then in this video, I am explaining an example of A-star algorithm. So let's start the example. In this example, we have a source node and only one goal node. Why I am saying that we have only one goal node? We have already seen in Dijkstra's algorithm that there was one source node and all the other nodes were goal nodes. But here there is only one goal node. That is the major difference between Dijkstra's algorithm and A-star algorithm, and all these remaining nodes are intermediate nodes. Okay. We have also learned that the cost to reach a node is denoted by f of n and is equal to the sum of g of n and h of n. Here g of n is actual value to reach that node from source node, and h of n is heuristic function. Heuristic function means an estimated value that is an estimation value to reach the goal node from that node. Okay. So firstly, we are now starting our example, and firstly we will find f of s. So f of s is equal to g of s plus h of s. So as we know, g of s is 0 because the cost to reach the source node from the source node is 0, obviously, and the heuristic value, here all these purple colored value is heuristic values of that node, particular node. So the heuristic value of this source node is 14. So I have written it here. So f of s will become 14. Okay. So now starting with the source node, as we have two different paths, s to a and s to b. Okay. Now we will find f of a, yes, and f of b. F of a is g of a. What is the actual value that requires to reach to the node a? That is 4. And what is the estimated value, heuristic value? That is 12. So f of a equal to 4 plus 12, that is 16. And f of b similarly, g of b is 3 and the heuristic value of b, that is 11. So f of b will become 14. Okay. So here f of b is less than f of a. Okay. So we will choose this path for our further traversing as to b path. Okay. So further we have two more paths, S to B and B to D, and S to B and B to C. Okay. So now f of C. So f of C equal to g of C, and what is the value of g of C? Is 3 plus this 7, actual value, that is 10. So f of C is 10 here, no? here is a mistake. F of c is here. This is f of d. Okay, first is f of d. Is not this. First is f of d. This is 3 plus 10, 13 plus heuristic value of d is 4. So f of d is equal to 17, and f here is f of c. Actual value of f of c, g of c is 10, and heuristic value is 6. So here 16, I have written 16. Here f of c is less than f of d. Okay, here f of c is less than f of d. So it is obvious that we will choose S to B path and B to C path. Okay, but remember the value of f of a. It was also 16. So we have now two possibilities. If we are going to S to B and then go to B to C, or either we can go to S to A directly. So first possibility, along the path S to A. Along the path S to A, we have two further paths, S to A and A to E, and S to A to D. So F of D along the path S to A and A to D, the value of D is, actual value will become 4 plus 12, 16, and the heuristic value of D is 4. So F of D will become 20, and F of E is actual value is 4 plus 5, 9, and the heuristic value is 11. Okay, so f of e will become 20, and the other possibility that we have is along the path S to B and B to C. Okay, so now we are at this node C, and we can only go to the node D. Okay, so we will find f of D along this path S to B and B to C path. Okay, so f of D value will become 3 plus 7 plus 2 is the actual cost, and 4 is the heuristic value. So actual cost is 12, and the heuristic value is 4. So f of D will become 16. Now all the three possibilities from all these three possibilities, we get 16 from this path, and from the first possibility we got two values, 20 and 20. So we have minimum value 16. So we will keep moving on this path. Okay, now from node D we can directly approach to the goal node. So the value of the goal node f of g will become 17, as 3 plus 7 plus 2 plus 5. Okay, and the heuristic value of this goal node is obviously 0, as the actual value of this source node is 0. Similar. So f of g will become 17. Okay, and we have reached the goal node with the minimum possible cost. Here we have completed our example, but what? But have you observed, in this example all these heuristic values are less than the actual values that are required to reach the goal node from that node. See, here it is 14, and what is actual cost? 4 plus 5, 9 plus 16, 25. Okay, so you can check all these values that are perfectly less than the actual values. So why we have to do this? So if we choose these less values, from the actual values, we can we can get optimal solution for to reach this goal node. Okay, it is this condition is called underestimation. Underestimation. There are two conditions: underestimation and overestimation. If we choose the condition of underestimation, we find the optimal and the best cost efficient route to reach the goal node. Okay, this shows the admissibility of this A star algorithm. Okay, so I hope you have understand this example very well, and all these topic that we have learned, that we have taught you, and so that's all from my side. Thank you for watching this video. This was the last video, so bye. Thank you for your support. Thank you very much.